Hello, I'm Sina Moallemi and I'm the product manager for RS3. In this video, we want to see how to display liner results in their local coordinate system and how to extract this data. In order to have a proper designs for the liner, the results such as axial load or bending moment should be transformed to the local coordinate of the liner. In this video, we want to see how to define this local coordinate and how to interpret the liner results. So let's jump into RS3 and see how we can do it. In this example, we have twin circular tunnels used for a railway system underneath the slope. In order to increase the stability of a slope, the soil layers are installed. The tunnels are created using our tunnel designer tool. So let's go over a few stages to see the sequence of excavation and the support installation. As you can see, after each stage of excavation, the shotcretes are installed in the next stage. For this model, I'm using a reset displacement functionality to exclude the initial deformation in the model due to the in-situ stresses. So all displacements that we see here are due to the tunnel excavation. To see how we can interpret the lining results, I have done the simulation for this model, so let's open the results. Let me switch the results to the total displacement. And as you can see, most of the displacement is localized around the tunnel. Now let's switch the data type to liners. We have different result types such as displacement, axial force, and moments. But all these directions are in global coordinate. Let's focus on one specific tunnel ring and define the local coordinate around it. I switch the selection mode to surface selection, hold Shift button, and pick any of the surfaces around the tunnel. All the surface is now selected. So I go to Support, Liners, define liner coordinate for tunnel. You can either input the tunnel direction by the vector or select one of the edges of the tunnel. I do the second one, which is simpler, and click OK. As you can see, the liner local coordinate is now created. The red arrow shows the local x direction, while the green and blue one are in y and z direction. Now you can see this liner local coordinate or tunnel frame is defined. So I can go and switch the results from the global frame to this new tunnel frame that we have defined and activate all the liner results and going to the last stage. So now, since we are in the local frame, if I want to see the hook forces, I can switch the data type to axial force in x direction. And now we are going to see the hook forces for the liners. Now let's see how we can extract this liner data using a query line. To define the liner query, I intersected with the cutting plane and asked the program to find the query line at the intersections. So I go and define a plane, and now I can set the location and the size of the plane. Here you can see where the plane is located, and I click OK. To define the query line, I'm going to select the cutting plane that we just defined and the liner intersecting the plane. Now I go to Interpret, Queries, Add Liner Query at Intersections. And for example, I'm going to pick 48 points for the query line. Now you can see the query line is created for us, and it's available in visibility tree. I'm going to select it and ask the program to graph the data. So now you can see the axial force in the local coordinate of the tunnel. You can also change the data type. And for example, if we want to see the bending moment, I'm going to switch the data type to moment about y-axis and click OK. And now we are going to see the bending moment around that ring. Now you can export all the data to Excel or any other program and check if the calculated results are in acceptable range for your design. In this video, we learned how to define linear local coordinate and how to create linear query to extract the data of the linear in this coordinate system. Thanks for watching. If you have any questions, please leave in the comment below.